Okay, so this is our last piece before we will do our story problem. We're going to find the coordinates on a unit circle. So we're going to use radians, and at pi over 6, when our angle is pi over 6, what is the x comma y value of that point, the coordinates? Well, this is how we do. This is a 30, 60, 90 degree triangle, because pi over 6 matches with 30 degrees, and I'm doing degrees because this is in degrees. Could do that in radians too though. So this is 30, 60, and 90. So across from the 30 is going to be 1/2, and across from the 60 is going to be √3 over 2. And those are just what we figured out here. Now, sine of 30 is going to equal opposite over hypotenuse. So this really is 1/2 divided by 1. A way that we're going to be thinking about this is multiply both sides by 1, or by the hypotenuse. And if you want to get your y coordinate, your y value, that is going to equal sine of 30 times the hypotenuse. Sine is opposite over hypotenuse. Sine of our angle is opposite over hypotenuse. The opposite is our y. Always. So if you want to get your y coordinate, multiply this side by the hypotenuse, and multiply this side by the hypotenuse. On the unit circle, the hypotenuse is always 1, so this is not really important on the unit circle. We don't really think about that very much. But there's a relationship that exists. Y equals the hypotenuse times the sine of our angle. And if we want to find the x coordinate, we're going to use cosine. So cosine of 30, cosine is adjacent over hypotenuse, so √3 over 2 over the hypotenuse, and √3 over 2 is our x value. So this is what's going to give us our x, times the hypotenuse on both sides. And we can have any angle in here, so I'm going to plug in theta. Our x coordinate is always our hypotenuse times cosine theta. So x, y. So to find the coordinates of a point right here, in terms of our angle and our radius, x is the hypotenuse times cos theta, and the y is the hypotenuse times sine theta. So this is our guide for finding the coordinates of any point on the unit circle. Okay, so let's jump into our story problem now that we have this down. Story problem says we've got a Ferris wheel, and if it's a radius of 45 meters. Okay, it's got 24 spokes on here. This is centered at the origin. "24 spokes, so 24 And I'm going to do, we're going to ask to solve this in terms of radians. and 24 spokes. In a whole circle, there's 2 pi radians. We're going to divide this by 24. We get 1 pi over 12. And we've got 1, 2, 3, 4, 5, 6, 7. We're asked to find 1, 2, 3, 4, 5, 6, 7, 8. We're asked to find the 8th seat. What's the coordinates of that 8th seat? Well, if each of these spaces means we go up by 1 pi over 12, or just pi over 12, and we're going up 1, 2, 3, 4, 5, 6, 7. It's kind of strange, it's the 8th seat, but we're finding the 7th angle, adding up all those angles. There's only 7 of them. 7 pi over 12. We want to find the coordinates of this point. Well, we have our radius, 45, and we have our angle. This is our theta. So we can just plug it into here. So our x value is going to be the hypotenuse, which is 45 meters, times cosine, 7 pi over 12. Our y coordinate will be the hypotenuse, 45 times sine, 7 pi over 12. And using radian mode in our calculator, 7 pi divided by 12 cosine times 45 . The diameter is not 45, the radius is not 45, the diameter is 45. So our radius is 22.5. So we're going to do 22.5. Guess it helps to read the problem, huh? Okay, so we're going to do cosine of 7 pi divided by 12 times 22.5, and we get 22.4. I'm going to have to stop there.